Is everyone else here today too?
Yeah, Cody should be here. Mason should be here. Destiny should be here. I just don't know where they are. Though I think Cody might be trying to drop it.
Why?
Well, he bombed this one as well, but so he really hopes that. Well, if he can drop it, I think he's planning on it. I don't know if he'll be able to though, because the date was last week.
I thought it was this week. Today.
Yeah, but so you could still technically drop it, but the last time to drop it for Jumpstart, they'll keep Jumpstart was last week.
Oh.
So, yeah. It's interesting. What you doing the test? Yeah.
All right, Menigo, can you see the screen?
Yep, we can see it.
All right. So, well, you missed 2 days. So, kind of briefly, I'll remind you what we were working on.
Thank you.
But it's just to calculate integrals. That's the list of all. And section 5.3, that's exactly what we spent 2 days on it. Talked about how we calculate integrals. And we have 2 theorems, and we call it fundamental theorems of calculus. The first one talked about the concept of antiderivative, and the second one basically told us how to find the integrals. But no matter what, when we're looking for the integral, we have to think about antiderivatives. So we had antiderivatives before in section 4.9, but now we are going to apply that concept to find an integral. Overall, we all should at least remember from sections 5.1 and 5.2 that integral in simple terms is the area under the curve, right? But also integral can be the distance because it's the same. Area under the curve is the distance. When we apply formula for distance equals rate times time. So those things we did last time. Now I'm going to put one example. I'm trying to remember it, but it doesn't make a lot of difference. So first that I have example, again, just quickly to remind you, it's the fundamental theorem calculus 1. So we're going to use this. And here's the problem that I have. Let's say I have function y equals, and I have integral, and I think I'm going to pick something similar to what you have on your homework assignment. Integral of cosine of x. So we have integral for lower limit cosine of x, for upper limit sine of x. And I think it was like natural log of 8 plus 9e dv. So what do we have here? We have function y that actually is the integral. It looks unusual, but what do we have here? We have the area, but this area does not have left and the right point as an interval. Okay, we're talking about here area that will change. So this y is the function that describes the area. And the question here that we have, again, according to this theorem, to find what y prime is. So we have to find derivative of this function. And the theorem basically says to do this. Now you have to look at the theorem, but the theorem basically says to do this. First, you have to look at the upper and lower limits. And none of them is a number, like from 5 to something. And theorem says we have to have this.
Mm-hmm.
So using one of the properties.
At the hospital.
No.
So using one of the properties, we have to
Yes,
split
it is digits.
an integral.
Who's your teacher?
No one would know.
This guy. These guys.
Okay, so one more time. In order for you to find the derivative, we have to follow the theorem. So you have to look at the theorem. But theorem saying is this, that the integral has to be from a number to something with x, let's say. But we don't have from a number. So we're going to split this integral into two integrals. So for example, cosine of x, and then you can put some number over here. And this is what we had before. This was section 5.2 to use this property. And the question normally we have here, like, what do I put here? How do I know what to put? And what did I say? It doesn't make a difference what number you put, as long as this number is from the domain. If this number is not from the domain, then I would say no, don't use it. So you can put, for example, 1 if you want. If you put 1 here, nothing will change, right? Domain will be perfectly fine. So put 1, 0 is still fine, but don't put anything negative because you may have it as a natural log of a negative number. So a number can go in. And then we have natural log of 8 plus 9b dv. And then the second integral will be from 1 to sine of x. And then we have the same thing. So again, the reason we're splitting because the theorem is pushing us to do this. The theorem only works if the lower limit is a number. So if you look at the second integral, we have integral from 1 to sine of x. This is what we're looking for. Now this one, the first one, is almost ready, except the lower limit has to be a number. So you have to flip upper and lower limits. And then according to the property, we have to put negative sign. So we're still not ready to take the derivative. We're just kind of working with the function. So for the first one again, as theorem said, I need to have number on the bottom and whatever I have with x on the top. So the property that we can use, we can flip this. So now I have 1, but I have to put this negative sign. Again, this was section 5.2. And here we have cosine of x, and then just copying everything. Okay, so that's what we have to do. Now, not every problem like this, okay, in terms of maybe complexity and difficulty, some of them much easier, but I picked the most difficult. So now we're ready to take the derivative. So again, when you look at the reason we split it, because we were looking for these numbers. I put 1, you can put 5, you can put 10, whatever you want to put. Here it doesn't make a difference. Numbers must be on the bottom, so that's why we split it, or flip this integral with upper and lower limits, and then we have to put negative sign. Now we're going to take the derivative. So how do we take the derivative? Well, it's not too difficult. In order to take derivative of this integral, working with the first one first, we'll move to the second one next, but working with this one, what we have to do, we have to take this cosine and substitute for v. But not to write the integral. Okay? Integration and differentiation, they're opposite processes, so we can actually cancel. When you take the derivative, you cancel the integral, but only if we're talking about x being on the top with something with x. So when you take the derivative, you get negative, that doesn't go anywhere. But then you have natural log, no more integral, taking the derivative of a plus 9 cosine of x. Oops, I forgot x, sorry, it's right here. Cosine of x. So cosine I substituted for v. Now if I have more of those v's, you put cosine for every v. And those who were here, what else I have to do? Right, and then you have to multiply by the derivative of your upper limit. So this will be negative sine of x. So this is the derivative of the first integral. Again, what you have to do, you have to take your upper limit, substitute for the variable, and then multiply by the derivative of the upper limit. Same thing we do with the second one. So here we have natural log of a plus 9 times by sine of x, and times by what? Times by cosine, meaning what? Derivative of sine. Oops, we said it was cosine, right? Well, and that's it. I don't want anything you to simplify except what's obvious here. Negative and negative, right? And you can keep it in this form. Well, for this example, there's absolutely nothing you can do. But overall, don't simplify. If you have a chance to work with the signs like here, then yes, but not LCDs and all that stuff. Alright, so that was example from the first theorem. Okay? That was the example from the first theorem. Well, now let's move on and work with the second theorem. Well, the second theorem helps us to actually to find a way to find integrals. And I'll give you the example. And we can actually start working right now. I feel it doesn't make a difference. But here's the fundamental theorem of calculus 2. It says this. If you are looking for the integral from a to b, f of x dx, so this time you have definite integral on specific interval, the theorem says that this function has to be continuous. That's very important. If this function is discontinuous on this interval, we have a problem. So we're assuming right now that f of x is continuous on this interval. So how do we take care of this? Well, we're going to find antiderivative, whatever that is. Let's say it's a capital F, and we will substitute upper limit minus, and we substitute what? Lower. And that's how we find definite integrals. So the main thing right now, you need to know antiderivatives. Now we had antiderivatives in section 4.9. You can always go back and refresh, but again, what's antiderivative? It's just going backwards, right? So if you really know your derivatives, then you know what antiderivative is. So let's take a look at one example here. So let's say, and I'm going to pick something a little bit more complicated. Okay, so let's say I have integral from 0 to 2, 2x cubed minus 6x plus 3 over x squared plus 1 dx. So, again, according to the theorem, I need to know the antiderivative of this whole thing. Now, if you kind of go back through all the derivatives that you had before, there's no such thing as this entire thing, right? If you go to the table, you just don't see it. So maybe you should try to look at this. Maybe I'll try to find antiderivative of this. Maybe I'll try to find antiderivative of this. And maybe I can try to find antiderivative of this. Now, if you start going through these steps and you say, oh, but I don't know what this is, well, maybe this method doesn't work. Maybe you have to create LCD and then work with the function. Okay, I'm just saying you how you have to think. But in this case, I'm just telling you, then we can actually go from left to right and just work with antiderivatives. So here's the simple question. What is antiderivative of 2x cubed? X to the fourth over 2. Don't forget, you're not taking the derivative. What do you have to do? You have to add 1 to 3. So 3 plus 1 is 4. Then you divide by 4. And 2 and 4 will be, well, 2 will cancel right here. So you get x to the fourth over 2. This is what we had in section 4.9. And we did a couple of problems last time too. Minus, now antiderivative here. What is antiderivative of 6x?
3x squared negative 3x squared.
Negative 3x squared. Don't get confused here. You're going backwards. You're not taking the derivative. But then, this is the biggest question. What is this? If you remember the table, right?
Is it tangent of 3x? Inverse tangent?
This is the inverse tangent. Now, that 3 is a coefficient, right? So what we get 3 inverse tangent of x. Now, you may say, well, how do we know? Well, because we had this before. What did you learn before? You learned that inverse tangent of x, and you take the derivative of it, you will have, well, according to the book, 1 over 1 plus x squared, right? That's the derivative of inverse tangent. So now I'm looking at my problem, what do I see? I see the same thing, yes, no? Except I'm looking at 3, well, 3 can be moved outside, that's the problem. And that means I know this is the tangent. So if you cannot make this connection, you're going to miss lots of problems. Okay, on the homework assignment, or on the next exam, or the final, let's say, because you have to see those derivatives. You have to understand how to go back. Just guessing or just picking something, that doesn't work. Okay, do you understand? So we know if you have 1 over x squared plus 1, it's our inverse tangent, right, as antiderivative. So, to continue with this, we put parentheses around, then we put brackets. And now, you were absent last time, so I have to explain what that is. What it basically, we're having one extra step before we go to the theorem. And that extra step is this. You find your antiderivative, and then you put this square bracket, well, this bracket right here, saying what? Now I will what? Substitute 2 minus what? I will substitute 0. So basically you're saying what antiderivative is here. So, equals. If you substitute 2 into the entire thing, don't just work with the first one, the whole thing. So 2 to the fourth is 16. 16 divided by 2 is what?
8.
8 minus, you put 2 here, you get minus 12, plus 3 times inverse tangent of 2, and there's no specific value for this, like pi over 2, pi over 3. You know what I'm saying? So you're going to keep it. You're not giving decimals. Okay? I don't take decimals with integrals. You have to give exact value. If there's a decimal, let's say, I will tell you, round and all that stuff. But you cannot just get your calculator, find what inverse tangent of 2 is, and then you start putting decimal here. There's nothing here about rounding, so don't rush to give me the decimal. Keep it exact. Well, the next step I have to substitute what? 0, right? So if you substitute 0 here, it's what?
0.
It's what?
0.
What about this? Now you're going to pause it. Well, what is inverse tangent at 0?
And 0 will only be 3 the whole term. It just be a 0, so.
It is 0. It's going through the origin. Now remember, it's like on the side. Like tangent flipped, right? It's going through the origin, okay? So it will be just minus 0. So I'm not going to write 0, 0, 0, right? It's just 0. So when we simplify this, we get negative 4 plus 3 inverse tangent of 2. And this is the answer. So again, the biggest thing that you have to pay attention to is the antiderivative. And not everything's so smooth and nice. We have to maybe modify the function. We maybe have to change the function. That's what we're going to look right now. And this problem a little bit larger, a little bit. Not too complex, but just larger. Okay, the next one, I don't know, I'm not numbering them. Do you want me to start numbering them? Where should I number? You want to put, let's continue. What this will be the number if you go from the last one.
14 last time. Finished on 14, so it's that.
So this will be 15?
Just start with
Yeah.
just one.
So now it'd be 16. Yeah, I think that'd be 16. Because the 14, we did the one with the first.
Okay, so, well, put 16. So that one was 15, right? Okay, so let's do this. And then we go to 17. And for 17, I have integral from 1 to 9. And then we have 2t squared plus t squared square root of t minus 1 and over t squared and dt. Now, one thing you have to be careful not to be confused right here. Now, here you will not be confused because you know when you're writing square root, you never put 2 right here as index, right? Now, what I'm saying is this. Look, let's say we have this. So here's the question. Is it t cubed or cube root of t? Well,
That's my guess.
what I'm saying here, I'm saying is this. You can have similar problem. When you start working on the problem, you may put this like this, and then you forget that this is what? T, for example, cubed. Or you forget that this is what? Cube root of t. And then you start working on the problem, not paying attention to this. So you have to be very careful. The way I put it, you can interpret it in 2 different ways. You can look at this, and again, this is still, it's going to look strange, but I'm talking about this, right? Or you can have t in there, what? Cube root of t. So when you do your homework assignment, you have to be very careful with the powers, not to put them in the wrong place. So what do I have here? I have t squared. Okay, this is what I have. Well, again, when I look for integral, according to the second theorem, I have to find antiderivative, right? Well, if you quickly go through the library and you had those formulas, there's no such thing like this, right? Like we had before, 3 over x squared plus 1. I know it's inverse tangent, right? But there's nothing like this. So what do you have to do? You have to change this to make sure you can use the antiderivative. So what we'll do here, we'll take every term on the top, 2t squared, and you will divide by what? T squared. So what are you trying to do here? You are trying to think about power rule. You're modifying the function. There's no such thing as this, okay? You can't do it right away. So we have integral from 1 to 9. We get 2, because we cannot use these, right? What do we get here?
Square root of t.
Square root of t, but I'm not going to write square root of t because you know we're talking about power function here. We'll go with t to it.
1/2.
1/2. Right? And this one will rewrite as t to negative 2.
Are you looking for someone in this Bateman's class? Yeah, this is Sturgeon quiz calculus class, so
Okay.
So
So now, we'll just go from left to right. So you see we have to modify the function. Well, technically, if we talk about this type of problem, this is the most easiest one because you're really working just with the process, nothing specific coming in. Comparing with the previous example, what we had inverse tangent, you really need to know the antiderivative because you have to recognize this right away. So going with this and working with antiderivative. So antiderivative of 2 is
2x.
2t, or, well, we don't have x, right? But it's 2t. Then antiderivative of t to 1 over 2.
2t to the 3 root 2.
And again, how do we know? We add in 1, right? So you get t to 3 halves. And then you divide by 3 halves. So 2 will go up. That's why we have 2/3. Okay? Now working with this one, what do we get? What's the antiderivative of t to negative 2?
Plus t to.
So you add 1, right? So you'll get negative 1 and you will divide by negative 1. So this becomes what? Positive, right? So you have plus. And you have t
1 over t.
to negative 1 or 1 over t. That's right. Both are okay for now. But actually, 1 over t will be a little bit better. Okay. So, what do we do now? We substitute. So we get 2 times 9 plus 2 times 9 to 3 halves over 3. And here I'm going to put 1 over 9. Okay, not 9 to negative 1, just 1 over 9. So that's the first substitution. So what is this? This is this. Where do I have it? I don't know. But this one is f of b. Okay, this whole thing we substitute 9. Now I'll do exactly the same, but I have to put minus, and I will substitute 1. So we have 2 times 1 plus 2 times 1 to 3 halves, you know it's just 1, and plus 1 over 1, well, I'll keep it this way that you can see. And after this, I think I mentioned this before, I'll say this again. You don't have to show me every step right now, like this is a 2. Okay? And this is 27 times by 2. But I want to see the answer right now. So you can just use your calculator from here. But I want to see antiderivative. I'd like to see substitution. And then just use your calculator to give me the answer.
I got 292 over 9.
Okay, so that's the right answer, right? 292 over 9. So, in this case, I hope you will not make a mistake when you're trying to calculate, okay? But again, calculator is not the best tool. You still have to put parentheses or other things to get around. But this is the answer. So, comparing the previous example where you had to recognize that inverse tangent, here it's a little bit different, but still you have to simplify or change the function that you can apply that power rule. That's what we have. So the question overall, well, is there any way that we can check if we're doing this right? That's the question. Because it's a lot of work, okay? Just you do something, you give the answer, and you never know if it's right unless you go back and start rethinking, and maybe if you made a mistake, you will catch whatever you did. But overall, how do I know if I did this right? So I'm going to help you. I'll tell you how this can be done. How can you check if you did this right? The only disadvantage that whatever you will get by checking will be decimal. You cannot give me decimals on the exam. So for example, this one has to be converted into a decimal, and then you will compare it's the same. But this is the answer, not the decimal. You are not going to give me any decimals. If we have natural log of 5, it's a natural log of 5. Because nowhere I will say round to something. Okay? Except there's one problem on the future exam where you have to round. But I'll tell you, but here's not. So let me show you how we check this. You need to have your graphing calculator for this. That's fine. You can see it. Now, your calculator maybe can do this if it's a Casio. That's why I can't let you use it on the exam. But right now, see if you can find the function. But your calculator actually has a function that help you to find integrals. So I'll show you how this we can do.
Yeah, it does actually.
Let's log in.
It does have that. That's nice.
So you go to y equals and enter the function. So I'm going to put function back. Now I know it kind of looks bad and big, but at least I want to check if it's right. So I'm going to open parenthesis, and I have 2x squared. Again, calculator doesn't have t for a simple function. Then we have plus, then I have x squared times by square root of x minus 1. So that's the top. Okay, now for newer versions of calculators, guys, I think you have a fraction, so you can just put this as the fraction. For older versions, 83, 83 plus, it's complicated. And then I'm going to divide this by x squared. Okay, so this is what I have. Now what I want you to do right now, I want you to graph your function. Alright, the main thing what you have to do. You want to make sure that your 9 is on the screen. Okay, the center. And also your 1 is on the screen. So the graph from 1 to 9 has to be visible to you. If you're 9 outside, let's say for example you were doing some other work and you changed the size of the window, now you put your function, your calculator will still keep the size of the window. So you may not see that 9. But you want to make sure you have the picture visible from 1 to 9, and I have this. Okay, so that's good. The next step what you do, you go to second trace, which is calculations. And if you look at number 7, it looks like integral. You see number 7? So it looks like integral. You either go down to 7 or hit 7, and then your calculator start asking lower limit. Well, lower limit is what? 1. Hit enter. Calculator is asking about what? Upper limit, which is what? 9. And then you're going to hit enter.
What?
And this is the answer. It says the integral equals to 32.444. Okay? Well, now let's take a look at our answer and see if it's the same. Is it the same?
Yeah.
Okay? It's the same. So 292. Let me go back. So I'm going to go to main window. 292 divided by 9 equals this. Now, again, I show you this to check, not to tell me that you use your calculator to find integrals. Because I need exact numbers. So please use this, even if you're doing your homework assignment. One thing, what I'm afraid, since I showed you now how to use your calculator, some students will not go through this. They'll jump right there, put the numbers and function into calculator, hit decimal, enter, get this 32.44, put it to WebAssign, and WebAssign is going to say you're right.
Yeah, I can't do that. Although my calculator does have the button, it takes like half, it actually once took a half hour to do a function.
So what I'm saying is be careful. You still have to show me all the work. I need to see, like I said, I need to see antiderivative, I need to see substitution, and then I like to see the answer. Use your calculator to find, just to check. You understand? Now, disadvantage here, I know we may think a calculator is the very magical tool. It's not. The disadvantage is that our calculator only can find integral speaking about area under the curve. And that's exactly what you see, just area under the curve. Do you understand? But in the future, we'll have some other types of areas that we have to find. For example, like area between the curves. And calculator cannot handle this. Calculator cannot do this. So you have to first set up the function, and only then after the setup you can put this into calculator. Okay, so it doesn't work straightforward. only for right now, this is okay. You can check this, you can see if it's working, if you're getting the right answer, but only to check. Do you understand? Now the next thing, you have other function here on your calculator that also can calculate the area under the curve, but you will not see the graph. So the only thing where you will see 32.44 as the answer, okay? So where's that function? Well, let's go back to the main window. When you hit math and start going down, you get to number 9. And then you see Fn int. Well, int stands for what? Integral Fn, maybe you don't know what that is, but it's similar to definite, it's finite. So basically we're looking for the value of the integral. But now I want you to pay attention.
What's the end derivative?
It's a numerical derivative. It's not the derivative like you take derivative of the function.
Okay.
So basically, at derivative will calculate slope of a tangent line. That's it.
He's still not here.
Let's do it. So, please listen carefully. This is important right now. When you hit enter, for the newer versions, you actually will have this. Newer, not mine. Mine is old. What you're going to have when you hit enter right now, and those, well, you can hit, all you can hit this, okay? But the newer version actually will have this. Integral, the box, I think the box here, and D the box. When I hit enter here, I don't get that. What do I get? This.
That's what you
Okay? And my task is more complicated than yours, guys, if you have this. Okay? If you have something like this. Okay? Why? Because I need to know how to set up the function. For you, you just put numbers here and put the function, put dx, and you're done. You understand? For me, it's more complicated. But look how, if you have older version, this is how it works. The first place over here, that's where your function is. But you already entered the function, so go recall the function with y variables. I don't know about the newer version. Can you put y sub 1 instead of this?
We'll go back.
Okay. Then you put comma. Then you're going to say calculate that your x is the variable. Then you put comma. Then you're going to say lower limit is 0, and then you say upper limit is 9. And you
Wasn't it
put
1 to 9?
oh, 1, right?
Yeah.
Okay, so I have to put 1, sorry. Alright, that's easy fix. So this is how it looks like for me. For a new version, it's going to look like this, and then you have to put some stuff in. So, if you hit enter, what will it get?
I can change that.
That's wait, see, the calculus is not that fast, and then you still have this.
32. You got it.
Still the same, right? Alright, so again, use your calculus to check, but they are pretty limited right now, because we only can check the area under the curve, nothing else. Alright, so the next thing, I'm going to jump, actually, what I did right now, actually it's in my notes for 5.4, but it's not a big difference for 5.3 that we had last time. Now, what is different in 5.4, that we are introducing new type of integral. Okay, let me take away this calculator. So, in 5.4, we're introducing new type of integral we call indefinite integral. But even if we have a new name, we're not going to do anything new. What is indefinite, and I mentioned this before, indefinite means you don't get the answer as a number here. What you will get a function. But that function still is the area. So concept of antiderivative is still present. There's nothing new. You still need to find antiderivative. Okay? So for example, how do we write indefinite integral? Well, indefinite integral doesn't have upper and lower limit. That's all we have. Just integral, And let's just get straight to the example. I'm not going to do anything special here right now. So this is what we call indefinite integral. Well, again, it's still antiderivative, right, to use to find. So what is antiderivative of x squared?
It's x over 3.
Right. And this time you have nothing to substitute, so you'll have your function. But as we had this in section 4.9, when we were talking about general antiderivative, you have to add last one. C. So that's the only difference that we have. Now, I mean, practically when we write this, when we do the work, this one's easier because you don't have to substitute anything, right? But antiderivative is still antiderivative. There's not a big difference here. Okay, you understand? Alright, so let's go to number 2. For example, we have integral again. We have 10 x to the 4th minus 2 secant squared of x dx. Now keep in mind, again, I've repeated this so many times, you all will be facing with a lot of challenges. What do I do next? Okay, I'm looking at this and I understand that I have to find antiderivative. But can I see antiderivative? That's another question. And here, since we have minus or plus, you can look at each term individually. So my question is this. Do you know what antiderivative of 10x to the 4th? Can you find it? X to the 5th. And we're saying yes, right? The next question, can you find antiderivative of this? So do you know what antiderivative of secant squared x? So this will be 2, right? And if you take antiderivative of secant squared, that's what? That will be tangent, right? Okay, so this one is a really straightforward problem, but you have to ask those questions. What do I know about antiderivative? So when we go over here, you told me this would be what? 2x to the 5th, right? Minus 2. And then we know that antiderivative of secant squared, you told me was what? Tangent of x and plus c. And there's nothing else you can do, combining, simplifying, and this is the answer. Okay? So, not too big, and we can do this individually. Now, I think I said this last time, and I believe I did. I'll repeat again. Last time, and medical, that's just for you, okay? Specifically for you. We're not there. Last time we had something like this. Integral from 2, and we had, I think, 4 minus t, excuse me, and times by square root of t dt. This is what we had. So, what I was telling in class, you cannot start looking at this as the product and start finding antiderivative separately. You cannot say, oh, let's find antiderivative of this. Oh, let's find antiderivative of this, and then multiply. It's not the way we do this. You cannot break the product. Also, you cannot have something like this, like we had before. What we had before? Like this 3 over x squared plus 1 dx. You cannot say, okay, we're looking for antiderivative. Let's find antiderivative of 3. Now let's find antiderivative of x squared plus 1, and let's just write it. This is not the way we do this. It doesn't work that way. There's no such thing as a product or a quotient in order to find antiderivative. You're looking at this whole thing as one function. You're looking at this whole thing as one function. And here what you have to do, you have to open parentheses. And that's it. Okay, here what do we have to do? We have to recognize that we have the first game. You understand? So please don't make that mistake. It seems like logically should be made that way, but this is not the case. We're looking at the function as the one function, not breaking function into pieces. Okay? So there's no such thing as antiderivative of a product or antiderivative of a
Would you
quotient
please come to the office?
does not exist. So, but if you look at this example, we can break this into pieces because of what? Negative sign, right? Remember we had the property. You can split it, integral. So please don't forget this. I'm going to repeat this all the time because I see this mistake made I don't know how many times, and it's just wrong. Now let's see. Let's take a look at the next one.
Oh, is that who's on the phone?
So let's say I have integral cosine of theta over sine squared of theta d theta.
He's so pretty.
How would you take care of this integral?
He's so pretty.
We have two ways to do it. We're going to use only one way today. But for section 5.5, we can pick up the second math. But obviously, if I think about my table, there's no such thing like this, right? And again, you cannot take antiderivative of cosine, and you cannot take antiderivative of sine squared. That doesn't work. The only thing what you can do, at least this time, is to what?
Separate it and create tangent.
That's right. If you separate this, and I'll put it this way. You understand? Just mathematical aspect of this, right? But why do we do this? Because 1 over sine is what? Cosecant. And cosine over sine is cotangent. So the next question, if I look at this function as cosecant times cotangent, do you know antiderivative? And antiderivative of this as the whole thing is negative cosecant. Why it's negative cosecant? Because when you take the derivative of negative cosecant, what do you get? Cosecant times, well, negative cosecant times by cotangent. You understand that? You have to see this in the table. Because, like, why do I split this? Well, just because I can? No, I split this function for the purpose. Because I see and I recognize that I will have this. And this one is very nice to work with because antiderivative of this is just this and we're done. You have to train kind of yourself to see those things. It only comes with practice, okay? Not just observing. You have to practice, you have to see, maybe you have to make a mistake, 1 or 2, but you will learn this, okay? So, we're almost done. I'm going to put, well, let's see if I need one more. No, I think we're okay. So let me show you the last problem right here. The last one. So, a little bit of practical aspect, okay? Right now we're just, again, looking for indefinite integral. Before we were looking for definite integral as the area under the curve. But also we can have tiny little bit more practical aspect. And actually we're using this in engineering, okay? When we're calculating the mass and some other things of the object. Or for example, we're banding, let's say the bridge, where the car goes, you know, it's going to start bending, so we need to know the force and everything else. All of this can be done with integrals. But it's not my area of expertise, so I'm not going to get into this. But here's the question that I have. This will be example 4. We have a function v of t, and this is the function of velocity. Okay, so this is the velocity that we have. T squared minus t minus 6. So this is the velocity. Well, the question here, I have 2 questions, is to find the displacement on interval from 1 to 4. Now, 1 and 4, those are what? Seconds or minutes if you want, you understand. So this is the interval from 1 second to 4 seconds or 1 minute to 4 minutes. That's what we have. This is time. So now we have to create the relationship. Okay, I say, okay, find the displacement. Now, what is the displacement? Because we have something similar to displacement, and that is the distance, right? Distance and displacement. Now, if I go back, for example, look, if I rewrite this like this, from A to B, I just want you to see why this is the displacement. And over here you have v of t dt, let's say we take in the integral, because we know if you go backwards, what is the antiderivative to velocity? How do we call it? Well, not exactly distance, but with the position function, right? But we can take it as a distance, but that's not exactly 100% true. It will be the position function, right? Now, also, what that means, it means the position function, if you take the derivative, will be what? V of t, yes, no? And that means, we talked about this last time when we had those three interesting problems. I don't know if you remember them. Remember those three that I told you what do we get? It's in the notes, just in case, if you didn't see. Remember, like, derivative of integral from 0 to 1, and that was 0, all that's what we're talking about. So look, v of t is actually what? S prime of t, right? So technically I have integral from a to b of s prime of t dt. This is just a substitution, no magic. V of t equals to this.
No magic.
But what that means, it means that s here is antiderivative, right? Yes, no? So what that means, s of b minus s of a. And what that means, it only shows the displacement, because if you look over here, it means what? I started from here, I ended up right here, and that's how far. This is how far I went. You understand this? This is not a distance. This is only the displacement. So when we look for the displacement, to make it easier, you just have to set up the integral.
Good afternoon, this is Superior Davina.
Nothing special.
We will have a dance food drive at the Century Cinemas Saturday, November 24th.
It's a
The
direct
showing will be
integral.
at 9 a.m. and 11
It's a
a.m.
displacement.
The movie showing are Jumanji and
It's easy
Social
to work with
Transformation.
antiderivative
The
here.
admission price
We're
is
gonna finish
$2
quickly.
with Joseph
We'll have
and all concession money will go towards
over
those
3
tickets.
minus t squared over
If
2
you are
minus
interested in
16.
attendance
And
for
you have to
Yeah.
or
substitute
charity teaching Janet on CSI during the second trimester. She has 5 available seats, so please go see her.
Okay, thank you, but let me just set up the way I want it.
Also, if you're a senior and you are graduating
So
with
4
your
cubed
associate's degree,
over
please
3
return 5
minus
each day.
4 squared over 9.
Just a reminder that we will be doing a gratitude
Minus
ball
6 times 4.
to get the spirit
So
for
that's the first
Thanksgiving, which is
substitution.
next,
And then minus,
beginning of next
I have
week.
to substitute 1.
This will take
1
place
over
after
3
our advisory
minus
will
1
be
over
up,
2
and then you will be
minus
able
6
to up the
times
gratitude
4.
ball.
The rest you calculate can handle this. So
The
what do we
next one
have?
is an activity known as
A
Ironworks.
minor.
This is an interactive assembly that brings students together. It will take
No,
place on
and again,
November
why it's
27th
negative
during the
because
first hour.
I went to the left instead
To
of
be
to
able
the
to
right.
attend,
Okay,
you
that's what
must
you
be
said.
passing all your
That's why
problems. If
displacement
you
is
would like to
wrong.
attend, sign up in the front office and pick up exclamation slip.
And I'm
Any
finishing
kind
with
of
the
fast
next
test, they
question.
can only take the first
For the next
126
question,
assignments.
he's saying find the distance.
If you are interested in the industrial maintenance program, don't forget that your applications are due today. If you did not get those applications, you can see Counselor, Mr. Lloyd, or Mr. Tate.
On the same
Don't
interval.
forget, those are due today.
Well, we know
If
that
you're
the
interested in going
distance
to
is
CSI,
basically
your
what?
representative is
Addition
Monday,
of
November
all
12th,
movements.
during
If you go to the
Come
left,
see what I
you go
do
to the
about
right, but the main thing,
We also want
they're
to
all
remind you
positive, right?
that the Spartan Fueling Station is open on Tuesdays
So,
and Thursdays after
In order for you to guarantee
That is all we
that
have for
everything is
today.
positive, you have to
Hope you
apply
guys have a
absolute
great
value.
weekend. Stay safe.
So,
Stay Spartan Remember,
distance
champions are
will be
made here.
integral from 1 up to 4, but absolute value of your function. That's what you have to do. The bad news right now, that we cannot just take integral of absolute value. The same thing like we had before with the limit of absolute value. You cannot keep absolute value. You have to get rid of it. And what that means, you will be splitting integrals into 2 integrals if you want to get rid of absolute value. But how? And that's where you have to graph the function. I have to finish this problem, okay? So, you graph your function, it's x squared without absolute value, minus x, minus 6, and I didn't get the price. Now this is what you get.
Software.
Now don't forget, you are working from 1 to 4, right? And if you look carefully from 1 to 4, there's one portion on the bottom, and one portion is where? On the top. But portion on the bottom is negative, right? But what do we say about this? It has to be what? Positive. So what that means, that bottom piece, you have to move up.
Do that, leave
In
it
order
here,
to make
and
it
get them started on the test.
Positive. So what that means, you have to split the integral from 1 to 3. And how do we know it's 3? Because what? It's right here. That's where you have this intersection. That's 3. From 1 to 3. But then you have to move this piece up. And to move this piece up, this over here, this little piece, you're using your function, but put negative in front of it. So this will be negative t squared minus t minus 6 dt. Okay, I'm almost done. I need like 1 minute.
Well, that's all you have. Go.
So again, taking the integral, breaking it into pieces, so we have from 1 to 3, then assigning negative sign for this portion, that guarantees that this bottom piece will move up, meaning when this becomes what? Positive, you understand?
No.
It becomes positive as the value. And then you have a second piece from 3 to 4, but you don't have to do anything here because it's already on the top. So t squared minus t minus 6 dt.
Anyone? I'm just
Again,
going to stop
take
this
the
now.
percentage change, and now you have to work that